Have you ever wondered how your smartwatch knows your heart rate, or how smart farms know when to water crops? These devices talk to each other just like humans talk using languages. But in the world of IoT, these languages are called communication protocols. Today, I will explain them as simply as possible. Imagine trying to talk to someone who only speaks French while you speak English. It won't work unless you both understand a common language. IoT devices are the same. Protocols are the common languages that allow them to share information. IoT means Internet of Things. It means all the gadgets and sensors that connect to the internet and talk to each other. It's like having a big team where every player shares information to get the job done. An IoT communication protocol is a set of rules that tells devices how to send and receive data. Think of it like traffic rules on the road. Without them, everything would crash and nothing would work smoothly. Here are the various types of IoT communication protocol. First, we have the MQTT, we have the HTTP, we have the CoAP, we have the LoRaWAN, which is used for long distance communication, we have the NB-IoT, and then we have the Bluetooth Low Energy. Now, talking about the MQTT, which stands for Message Queuing Telemetry Transport. MQTT is like a smart postman. But instead of big boxes, he delivers tiny specific letters just to the houses that asked for them. This postman doesn't knock on every door, only the ones that sign up for a particular message. So this is the simplest way to describe how the MQTT works, which is the Message Queuing Telemetry Transport. This is how the MQTT works behind the scenes. Devices like sensors or controllers either publish messages or subscribe to them, but they never talk to each other directly. Instead, everything passes through a middleman called the broker. As you can see on screen, you can see the broker, and that's our MQTT post office as discussed earlier. Let's take a simple example. A device sends an on message to the topic, which happens to be the home/office/the lamp. What happens is that the ESP32 microcontroller that controls your lamp is subscribed to that topic, which is the home, which is /the office/lamp that represents the topic. So as soon as it receives the on message, it turns the lamp on, just like that. It also works the other way around. A sensor in your home or garden might send humidity or temperature data every few seconds. That data goes to the broker, and any app or device that is subscribed gets the updates instantly. So you can see the sensor which publishes the data, and then it gets to the MQTT broker, and then it gets to the application which subscribes to that particular data. So remember, MQTT is like a smart postman. He doesn't carry junk. He delivers only what's needed to only those who asked. That's why MQTT is perfect for smart devices. It's fast, lightweight, and reliable, even with low internet speed. And that's MQTT made simple. A postman, smart messages, and houses that only gets the mail they need. The next IoT protocol is HTTP. HTTP is the same language your web browser uses, but it's like sending a big heavy box for just a small message. It works, but it's not very fast or efficient for IoT devices. Let's say your ESP32 wants to send temperature data to a cloud server. It uses HTTP just like your web browser, but unlike a browser loading a web page, the ESP32 sends sensor data, say every 10 seconds, and that data is wrapped in a full HTTP request. Let's take this ESP32 web server sent event example, where we get to update sensor readings automatically. You will notice that each time HTTP opens a new connection, it sends the full request and then it closes it. And when that happens, that's power hungry and inefficient for small devices. And this is exactly what HTTP does. It sends simple message using big packaging. It works, but it's not very efficient. It's not an efficient way, especially for small IoT devices like sensors. Next on our IoT communication protocol is CoAP. CoAP is like a faster, lighter version of HTTP. It's built for tiny devices that don't have much power but need to send information quickly. CoAP stands for Constrained Application Protocol, which is a simple way for tiny devices like sensors to talk to each other over the internet. So think of it as a tiny messenger built for low power and low memory devices. Like I said, CoAP is a lightweight way for small devices like sensors to send data. In this setup, we have two CoAP clients, tiny devices that collect or send information. The first CoAP client sends its data to a CoAP gateway. The gateway converts the CoAP message into either MQTT or HTTP, so it can be understood by the main server, which is like the cloud, as you can see on screen. The second CoAP client is more advanced. It sends its message directly to the server using CoAP without needing a gateway. This shows how CoAP works flexibly with different setups, either through a translator or directly. To understand the working principle of CoAP in a typical IoT setup, there is a central system called the Network Management System, or the NMS, as you can see on screen. It sends commands using regular web language called the HTTP, as we've discussed earlier. But CoAP devices don't understand HTTP, so we use a proxy, which is a middle translator called the HTTP CoAP proxy. This proxy converts the HTTP message into a CoAP message which travels over the backhaul network, and that's the connection between the internet and IoT devices, and then it reaches the small devices like the sensors and the actuators. Sometimes the NMS, which is the Network Management System, can skip the proxy and speak to the CoAP directly. And even better, CoAP devices can talk to each other too, which saves time and bandwidth. Next on our IoT communication protocol is LoRaWAN. LoRaWAN is perfect for sending messages over really long distances, like from a farm sensor to a control center, even if they are kilometers apart. LoRaWAN stands for Long Range Wide Area Network. It is a wireless communication protocol used in IoT systems to send small amounts of data over long distances while using very low or little power. These are the LoRaWAN network features. Here are what makes LoRaWAN special. First is it works over kilometers, even in rural areas, so it covers long range. All right, and next is that it's extremely power efficient and it's perfect for battery powered sensors, so it has maximum battery life, very low power usage. All right, and then it also has a multi-usage characteristics. All right, and then it's cost effective, low cost. LoRaWAN is everywhere, and one of its applications is in IoT weather monitoring for monitoring atmospheric conditions. Other applications are in smart cities to manage parking or monitor pollution, in agriculture to track soil and livestock, in industry to also monitor machines, and even in smart buildings for automations. So you can see here in water monitoring and various applications of LoRaWAN. Let's now understand how LoRaWAN works by looking at the LoRaWAN network architecture. So the first thing on screen are the end nodes. The end nodes, they are like sensors that collect data and send it wirelessly using LoRa. So that data travels through LoRaWAN communication to a gateway. You can see how the data is traveling from the end nodes to a gateway as labeled on screen. So the gateway forwards it via either Wi-Fi or Ethernet or cellular. So that data is either forward, it can either be Wi-Fi or it can be forward through Ethernet or through cellular, and it goes straight to a network server. So once it gets to the network server filters and forwards the data to the application server where it is processed. All right, and then finally, the data reaches cloud IoT services for storage, for analysis, or for dashboard viewing. So LoRaWAN makes long-range, low-power communication very possible, and it's ideal for smart solutions everywhere, just as we saw on the IoT weather station for monitoring atmospheric conditions. All right, so LoRaWAN, it's a very important IoT communication protocol. NB-IoT, narrowband Internet of Things, uses mobile phone towers to send data. It's great for things like smart streetlights or parking sensors in busy cities. Imagine a network that quietly connects devices hidden in basements, underground, or out in the countryside and keeps them running for over 10 years on a tiny battery. That's NB-IoT, which is a narrowband IoT. Narrowband IoT is a low power, wide area technology that runs on existing 4G networks and is perfect for devices that don't send much data, just a little once in a while. Narrowband IoT is secure, is power efficient, and has great range even inside buildings, rural farms, and it's used for smart meters, tracking, smart cities, agriculture, and even lighting and parking. So here are the benefits of NB-IoT. The next IoT communication protocol is the Bluetooth Low Energy, BLE. The Bluetooth Low Energy is like two friends whispering in the same room. It's great for wearables like fitness trackers, but only works over short distances. So whenever you're working on a project that requires short range chat or short distance communication, the Bluetooth Low Energy, BLE, is the best IoT communication protocol to use. Bluetooth Low Energy, BLE, is a wireless communication protocol designed specifically for devices that need to send small amounts of data while using as little power as possible. It's perfect for devices like smart watches, heart rate monitors, and home sensors that run on tiny batteries and need to last for months or even years. So this is an example of a Bluetooth Low Energy connection. Choosing the right protocol depends on what you are building. If it's long distance and low power, LoRaWAN is perfect. For real-time updates, MQTT wins. And for wearables, Bluetooth Low Energy is your best friend. So protocols are just the ways IoT devices talk to each other. Each has its own strength. So if you want to see real IoT projects using these protocols, subscribe to my channel if you are new to this channel, and give me a thumbs up if you enjoyed this video. Thank you for watching. See you in my next video, and bye bye.